Welcome to the Carolina Weather Group for November 6, 2019, show number 299. So close to 300. So close we can taste it. I'm Jared Smith in Charleston, South Carolina. We got a pretty full panel tonight. We've got Tim Pounds, Evan Fisher, Peter Planamente, Ricky Matthews, Shay Gibson, and all of you at home. So I am very excited to have everybody with you. And tonight we have Elsayed Talaat, the director of the Office of Projects Planning and Analysis at NOAA's Satellite Information Service, about the Cosmic 2 project. It's an experiment that looks at our weather in a different way than we might be used to from weather satellites. And we're going to learn a lot about that tonight. I'm really excited about it. It's really cool. Before we bring them in, though, we're going to just do a couple housekeeping notes. As always, this is a live broadcast, so we'd love your questions and comments for our guest. And if you're listening to us on the audio podcast, never fear, we're going to get all the information that you can find out more about Cosmic 2 towards the end of the interview. And then we're going to go and talk a little bit about some scary Halloween tornadoes, and we're going to talk about a big old cold blast that's going to be coming our way. So lots to get to tonight, so let's just get right into it. So Dr. Talaat, welcome. Welcome to the show. First timers, so we always like to ask how you got into this weather thing.
Well, I was aerospace engineer as an undergrad, and I was very interested in how we can make measurements of the environment and and space as well. So for graduate school, I went into atmospheric and space physics, and where I learned both weather, terrestrial weather, planetary weather, weather on other planets, and also space physics as well. So what we call space weather, the events on the sun and in the near Earth environment that can affect our technological society. And so from that, I progressed into research on space weather and also the atmosphere, and then eventually found myself my way to NOAA, where I can help the weather enterprise and make the measurements that we need to protect our society.
That's excellent. That's way cooler than any of my path, that's for sure. Holy cow! So let's talk a little bit about Cosmic 2. This is a very interesting project using a constellation of satellites that use GPS signals in an interesting way. Tell us all about it.
So Cosmic 2 uses a technique called radio occultation as its main way of measuring the atmosphere. And what that is that GPS sends out signals, and all global navigation satellites send out signals. And as those signals pass through the atmosphere, they're bent, they're refracted, and the signals are bent, just like you see refraction through a prism. Or through water. And from the bending, we can deduce properties of the atmosphere. We can measure, we know that the refraction is caused by temperature changes, density changes, water vapor in the atmosphere, and also the electron content and the ion content in the atmosphere. And so we can deduce properties of the atmosphere by measuring how the bending happens when we measure it from satellites that are in low Earth orbit. And so that's the occultation part. As the satellite moves around the Earth, it's receiving the GPS signals, and the signals are being bent and occulted by the atmosphere of the Earth, and that way we can get vertical profiles of temperature, density, and electron density in the atmosphere, as well as water vapor.
Wow, that is incredibly high level. I'm trying to wrap my mind around how some of that works. So can you explain a little bit about how once the GPS signals and radio occultation occurs, I'm going to ask a really lame question because I don't know what I'm talking about here. Are there disks on the ground that perhaps measure those bent rays? I mean, how is that, once they send out the signal, how does it come back?
So the signals are sent continuously by the global navigation satellites, and your cell phone uses those signals for positioning as well. And then if you have a GPS in your car, that uses those signals for positioning and finding location where you are as well. But when you see, and then we can also measure those properties of the atmosphere and ionosphere in particular from receivers on the ground by looking at the delay in the signals and looking at different frequencies, the several frequencies that these global navigation satellites send out. And from that delay, we can deduce the kind of the column of the electron density in the atmosphere, for instance, or what's called total electron content. But when we're in low Earth orbit, the path that these signals take is through kind of the layer of the atmosphere as it goes through like this. The path from a GPS satellite to a low Earth orbit satellite goes through the atmosphere, and that is bent by the properties of the atmosphere. And then we have instruments on the Cosmic 2 satellites and other satellites that use radio occultation that measure the GPS signals, and at a very high rate. And by looking at the time and the different frequencies of the signals, we can deduce how much bending happened of the signals from the satellites. And that way we can figure out what the temperature and pressure and density are.
How did the idea to do something like this come about? Was it something that was being used in other research ideas or monitoring other things using the same kind of method, and then was applied to weather?
Actually, it's a good question. I don't know the history of the first GPS occultation, but it's something that they knew that the signals from GPS satellites were affected by weather, by the properties of the atmosphere and the ionosphere from the very first beginning. This is electromagnetic wave propagation. We know that they're going to be affected. And then scientists were able to use that information to exploit and see if they could measure the effect well enough that they can find the properties and retrieve the properties of temperature and pressure and ionosphere. It was a technique that was tested out a few decades ago, actually, through planes and other means on the ground as well. But the first satellites that used radio occultation happened actually a couple of decades ago, when we tested out the instruments on satellites. And then Cosmic 2 is actually building upon the success we had with Cosmic 1, which was also a joint US-Taiwan suite of satellites, 6 satellites, that primarily use radio occultation to measure the atmosphere and the ionosphere.
So Cosmic 2 is actually a constellation of satellites, correct? It's not just one satellite. Talk about them working together.
Okay. So yes, it's 6 satellites. They're in low Earth orbit, and they've got a subtropical inclination. So they're focused on measurements at the near the equator and in the subtropics. And by having 6 satellites, we can get a very dense coverage, both in geographic coverage of the occultations, but also, just as importantly, in local time at any one second. So the ultimate, the final constellation that we're going to have is going to be 6 satellites separated in local time around the Earth, so that you'll measure, they're 2 hours apart, and they'll be able to measure all local times at the same time, basically, and global coverage instantaneously.
What is the, I guess, end game with this data? Has it been thought as to where this data will go? Will it be eventually implemented into weather models, or will they, kind of use it for more research purposes? What's the end game with it?
Yes and yes. So why we are primarily interested in using this data, and it's been proven to radio occultation data has been proven already through Cosmic 1 and other radio occultation measurements, to improve the numerical weather prediction models. And so with Cosmic 2, we anticipate the same impact on our numerical weather prediction systems. But also, it's certainly going to be used for research as well. the dense coverage we're going to get from Cosmic 2 is fairly unprecedented in terms of the coverage of moisture and the cover in the tropical region where most of the moisture in the atmosphere resides, and in terms of the dense coverage of temperature and density and pressure there as well. And I also want to mention that the ionosphere, it also will give us a whole new set of measurements for the ionosphere, very dense coverage that we're going to use, the US is going to use to essentially kickstart our numerical ionospheric prediction system, a data assimilation for us ionosphere as well. And so that's going to be a leap forward that we anticipate from the Cosmic 2 measurements.
Very cool. I want to get back to the ionosphere because I want to understand more of what you're looking at in the ionosphere. For those watching, what that means, but also I want to ask: do you work at all with the Cygnus? Like, we know of other satellite constellations that are out there. Cygnus launched a couple of years ago. There's 7 in that one. A-Train. There's other one. There's a whole bunch of these constellations out there. Are they working together to get data pretty much compiled for all the dynamic and statistical modeling that you're looking for?
So we are actually, that's to answer your second question first. We are actually looking at how we can utilize Cygnus in an operational sense at NOAA. So it's got its original purpose was to look at ocean winds, or I should say winds in hurricanes and cyclones. And so we're seeing how we can use that data right now. It's something that we're very interested in, a future capability, for instance, and whether we can actually use the data in a real-time sense also from the mission as it is. The other aspect of Cygnus that is very exciting is that the GPS reflectance. So Cygnus is a little different. It's the same sort of instrument, using the GNSS signals, but instead of looking at the occultation that happens to those GNSS signals in the atmosphere, it's looking at the reflectance of those signals and off of the hurricanes or off of the ground, or off of the ocean surface, and that way it can look at winds off of water. But and that's how it would get the ocean and hurricane winds. But over land, it's actually proving a very interesting technique to look at groundwater and how and flooding, for instance, and river proliferation and water proliferation through rivers and channels. So that's a technique that we think might be very useful for our operational purposes and research as well. To kind of answer your another part of that question, the way we use these data in concert, sometimes it's in directly in numerical weather prediction in a real-time sense. Sometimes it's through kind of combined analysis of different types of data synthesized into, for instance, sea surface height, or a combined analysis that doesn't need that real-time aspect to it, but is something that is needed by scientists or operators as in a less than a real-time sense. And oftentimes, and always, we use it for research. We combine the different types of data, and each has its own advantages in terms of cadence or coverage, or a different way of attacking the measurement, and used that way. So one advantage of radio occultation is that it's essentially self-calibrating. It's got absolute calibration. And so it can be used to help calibrate or help define the altitudes for other types of measurements. So we do infrared soundings and microwave soundings that are integral to our weather forecasting and weather operations. And they have their own advantages and disadvantages. But one thing that they those two techniques have is that the weighting function, in other words, where the information is coming from, is spread over altitudes in the atmospheric column. So what radio occultation allows us to do is help define where, in a statistical sense, to help calibrate where the signals are coming from those other techniques. So it actually improves how we use the other parts of our weather observing systems.
So like advanced scatterometer readings, like are those still being used, or is that part of your program, or is that mainly limited to ASCAT?
The scatterometry system is used both ASCAT and then kind of the other frequency that was available from SCATSAT, the Indian mission. And in fact, we have a partnership with India to obtain that data in real time, where we're using one of our ground stations to help the latency of that data, and provide it to operators in real time. So all that data, all information that we can, we look at how we can use it both operationally and in research as well. Very good.
Getting back to the original question, was you're looking at the ionosphere in particular. Yeah. What exactly are you looking for? What sort of properties are we kind of going for the data?
So Cosmic 2 is going to be is hopefully going to be a very large boon to ionospheric research. Cosmic 1 certainly was. It provided us a very dense coverage, kind of unprecedented coverage of the ionosphere, and helped us define the morphology of the ionosphere better than we've ever done before. And Cosmic 2, with its dense set of measurements, is definitely going to do that. And the lower atmosphere is a very dynamic region of the ionosphere. The lower latitudes are a very dynamic region of the ionosphere. So understanding the physics there is very important to the whole global system, electrodynamic global system. And in particular, we're also going to be looking at, and why we care about the ionosphere is because that's it can affect the GPS and GNSS, so the Global Navigation Satellite System, signals in terms of disrupting navigation and positioning of those signals, and also can affect high frequency communications. And so the different things that can affect it in the ionosphere are both the large scale morphology, the different gradients that you see in the ionosphere, any movement in the ionosphere, any change, rapid change, which can happen because of geomagnetic forcing or even lower atmosphere forcing can affect that. But also the very small scale changes are the ones that really affect the navigation, so disrupt the navigation systems. And that's called scintillation. Very small changes, very small scale disturbances or features or waves in the ionosphere that can affect navigation systems. And that's something that Cosmic 2 will be able to both allow us to research and kind of give us maps of statistically where that scintillation is happening, under what conditions, and possibly in the future maybe give us a real-time capability to both nowcast and maybe forecast that scintillation.
So is Cosmic 2 a big upgrade from Cosmic 1? Can you explain the difference between the two different systems?
Yeah, I'll explain. The big improvement is the big upgrade, I would say, is in the improvement in the radio occultation instrument itself. It's the Tri-G, the TGRS, the Tri Global Navigation System Satellite, Global Navigation Satellite System Radio Occultation System Instrument. So TGRS for short.
We love acronyms in weather.
Yeah, and that instrument is a major improvement. Is able to, the first generation of cosmic radio occultation instruments looked at GPS satellites. This one is going to be able to look at GPS and GLONASS, And hopefully in the future, if we are able to do the software upgrades, to look at Galileo as well. So that's where the tri-G comes in. And so that increases the number of occultations that it can actually make. And as well as improvements in the processors, it actually has 2 sets of processors so that it can make those additional occultations. So we're going to get quantitatively many more occultations than we did from Cosmic 1. In addition, there's a difference in the inclination. Cosmic 1 was in a near high latitude inclination, such that it was able to make global measurements in both local time, is spaced around in local time as well, 6 satellites. But it was also making a good latitude extent out into the poles even. But that meant at the equator, it was very sparse data. Cosmic 1 is in a low latitude inclination. And so between 40 and 40, this is where it makes its measurements, 40 degrees latitude and 40 degrees latitude north and south. It's very, very high density data. And this is the region that, from a numerical weather prediction, we believe is going to be very instrumental in advancing our capability, because this is the region, of course, where cyclones start to form, tropical storms and cyclones form, where hurricanes get their start before they propagate out into mid latitudes. And this is obviously of course the region also where most of the moisture of the atmosphere is there, and so most of the engine that drives severe weather is there. And so having that very dense measurements, more measurements and very dense measurements is going to be very impactful. Now, there's another improvement to the instruments, is that Cosmic 2 has better antennas to receive the signal from the GPS or GNSS satellites. And so that allows us to penetrate. What I mean by penetrate means that we can get signals at higher quality, in other words, less error, more power, down into the lower atmosphere, further down near the surface. And so the one limitation of previous occultation, radio occultation measurements, has been down below. It's been too noisy to really use in numerical weather prediction. But with Cosmic 2, it can make higher quality measurements down lower, again, where most of the moisture is, and that's one of the holy grails of atmospheric science, is getting those measurements in the planetary boundary layer down lower. And so again, we feel that once that's fully utilized by the numerical weather prediction systems, and they do have to evolve in order to use that optimally down below, that's going to be incredibly impactful.
We've talked a lot about weather prediction and how it's measuring, temperature and moisture levels, and how that can impact numerical weather prediction models. Talk about climate for a second. Are we going to be able to monitor our global climate better with the Cosmic 2 satellite?
Well, I think it's just in the context of being able to make continue the measurements that we have in temperature and pressure with a radio occultation technique, which I said is self-calibrating. And so that's something that's we started doing in the early 2000s, and having that continuous measurement would help kind of long-term trends of understanding temperature and pressure and density. And again, it helps also calibrate the other instruments that also have a long history, and then are going to be key in the future for our both the weather record and weather prediction.
Tell me just a little bit about the guys and women, the women and men who are taking this data once it comes from the satellite. Who are the people on the ground who are then diving into this data, and what do they have to do with the data when it comes back from the satellite?
Okay, so let me first by saying that Cosmic 2, which is also known as Formosat 7 in Taiwan, is a partnership between the United States and Taiwan. and so I'll kind of go into what the two partners' responsibilities are. So Taiwan provided the satellite and is doing the command and control of the satellites. The U.S., the NOAA and its partners, the U.S. Air Force, provided the instruments. And also Taiwan has provided 1 ground station. The U.S. is providing 9 ground stations for getting that data. So once we get the data, whether it's from the Taiwanese ground station or the U.S. ground station, they're distributed all around the world. Ground stations are distributed evenly around the world, or as evenly as possible, in order to get the best latency of that data. Latency is very key to making it useful for numerical weather prediction and ionospheric weather prediction, or ionospheric nowcasting. And so once that data is received, it's distributed to all our partners. But in particular, it's analyzed by it's first analyzed by a U.S. Data Processing Center, and we do this. NOAA works with the University Center for Atmospheric Research. We contract out to them to get the processing done and produce the temperature and density and ionospheric density of that data. And it's also produced at the Taiwanese Data Processing Center as well. And then that is going to be shared to basically all our weather partners.
Awesome. So it's really great whenever we have these global camaraderies and global partnerships with different nations and stuff, sharing our data and everything like that. So really cool. What is the future? Give me a dream of yours the next 5 years. What do you envision this project being? And maybe I'm going too wide in 5 years, but get the next 5 years or something like that.
Well, I hope fairly soon we'll be able to I just want to say that we are still in the satellite phasing time for the mission. So we're not even on our final configuration until about a year later from now, a year and a little bit later from now. But I hope once that's done, we are able to see how much impact it has on the numerical weather prediction models, because that is the one of the main reasons we flew these satellites and are making these measurements. I think in the far future, Cosmic 2 has a mission life of 5 years, and Cosmic 1 lasted for a lot longer than that. We even still have 1 satellite still making measurements, though sporadically. And I hope Cosmic 2 lasts past 5 years. And we are developing the radio occultation technique into the future. I think it still has promise in terms of in both improving the instrumentation, but also in the novel uses that we now see, for instance, with Cygnus, the ground reflectance and the measurements over the ocean. And so adding that capability and understanding that capability to any future techniques would be very exciting. And then there's also now commercial providers of radio occultation, and that is something that we're investigating right now. If we can use that to augment our system and increase our coverage, particularly in mid and high latitudes.
All right, awesome. Well, with that, I'll give it back to Jared, kind of wrap up everything.
Yeah, no, thank you very much. This has been fantastic. I do have another additional question before we kind of figure out, I would love to know where is this data ever going to be out there for like operational usage? Because I feel like that there would be a lot of value in having these kinds of real-time measurements, not just for feeding the models, but also just for line forecasters, just trying to keep an eye on things.
Yes. The plan is that we just recently, on October 21st, we had the satellite initial operational capability. We verified that. We're going to start giving provisional data to our partners at the end of this month or the beginning of next month. And in February, we plan to have a neutral atmosphere initial operating capability, where we basically release the data to the public and our partners for evaluation. And then so June plus 19 months. I can't do the math in my head. Basically, end of November in 2020 is when we have the final operational capability, and that's where all the 6 spacecraft are in their final configuration, and the data is released both for the neutral atmosphere and ionosphere to the public. And when I say it's released, it's going to be resident in as soon as it's processed on the system that provides data to weather forecasters around the world, and also on the web for the public to use as well.
Right now, it's basically in experimental mode right now, correct? That would be.
Yeah. So we're validating the algorithms, validating the data, getting it ready to use for, and in February we'll have the initial operating capability.
That's fantastic. Definitely look forward to it. That's years a long way, but maybe not as long as we think. So really exciting to see that, and it'll be exciting to see, just this technique alongside the imaging that we have, on the current series of GHOST satellites, and just yet another, and then the polar orbiting there. I think we're just getting really good at monitoring the atmosphere, and it's just I love this stuff. It's just so fascinating. So, where can we find out more about Cosmic 2? Places for our listeners to dial up some information.
You can find it on the NOAA website on Cosmic 2. There's also a UCAR website. That's where our main Cosmic 2 website is. And so search for Cosmic 2 and NOAA, and Cosmic 2 for UCAR. Yeah.
Cool. Do you all have any social media that people can follow?
Yes, the NESDIS social media, Twitter. I'm familiar with. I'm sure there's others as well. But the NESDIS, NOAA NESDIS, NESDIS.
Awesome. Thank you so much, Dr. Talaat, tonight. This is really fantastic. A lot of really good information. I know that we have a few panelists whose minds are currently blown, so we're going to give them an opportunity to put that all back together for them. And thank you again very much. This is fantastic, and looking forward to seeing the data this time next year, maybe. So, and we should have you back around then. So
it was my pleasure. Awesome. Happy to come back.
Awesome. Thank you so much. All right. And so, again, Dr. Elsayed Talaat, very fascinating, very just the radio occultation. I think a lot of people learned a lot of new words tonight. So that is a lot of fun. So now what we're going to do is we're going to toss to our friend up in Jersey, Mr. Peter Planamente. He's going to talk a little weather news for us. We, as you probably knew from last week, we had a bit of a severe weather event for Halloween. That's was a little bit scary with everybody trick-or-treating. Peter, what have you got for us as far as what came out of that event?
Yeah, let's get to that news right now. Let me do a little screen share. Hopefully that'll come up. Hopefully. All right, here we go. So, we had a few tornadoes touch down around Halloween, pretty much the end of October. And you can see the National Weather Service confirm that. Here's the first one. If I pronounce anything wrong, forgive me. Not from the area, so, don't shoot me. So an EF0 tornado confirmed on the 22nd of October. It started around, I'm not even going to try to pronounce that. But anyway, I'm guessing. Okay, there you go. So
wow, our Jersey guy's coming in great here. On the
yeah, I
Carolina Weather
mean,
Group.
the wrong one to be doing this. But all right, anyway, so at EF0 with the wind speed of 70 miles an hour, had a path width of 50 yards, but luckily no fatalities or injuries, so that was a good thing. And then we go on to Halloween Day. National Weather Service confirmed on the 1st, November 1st, that there were multiple touchdowns of an EF1 tornado in Lexington County, and also a tornado touchdown 3 times in just over 8 miles from the same supercell. Crazy, right? So luckily, all of those did not have any fatalities or injuries. But the first one had a wind speed of 95 miles an hour, so pretty bad, and did cause some large tree limbs to be down, some uprooted trees, snapped a couple of softwood trees, approximately 20 to 30 feet off the ground. And also, strong winds blew a piece of sheet metal that wrapped itself around a tree trunk. So that's some pretty crazy damage. And also, we had a tornado touchdown near Clinton Seeds Farms along Old Farm Road. The tornado continued northeast and uprooted and snapped nearly 24 trees. And also, a small wood building at the farm was lost, and the metal roof blew off. So, yeah, we had some pretty crazy damage down there in the Carolinas. Very spooky, ominous weather for Halloween. I guess Mother Nature had to stick her 2 cents in somehow with the trick-or-treaters or whatever. So luckily, like I said, no fatalities, no injuries. So that's a good thing. I guess the warnings came out early enough for everyone to take cover, and it all worked out in the end. So, Jared, send it back to you.
Thanks, Peter. And I got to say, I was watching that event unfold. It was very well forecast. I think a lot of people took the warning seriously. There was a lot of trick or treating that was delayed, especially up towards Charlotte, and that seemed to work out really well. So kudos to the meteorologists who were in the way. We talked to Brad Panovich and Tim Buckley last week. You can find our episode. They gave a really good breakdown of it, and it went off as advertised, for better or worse. That Lexington storm was scary. That thing that had a tornado debris signature on it, and that is the last possible thing you want to see when you have a bunch of kids potentially headed out for trick-or-treating. So good on everybody for heeding the warnings. Glad nobody was seriously hurt, and and we can always weak storms, nothing crazy, but we did get a nice little shot of cold out of that. It's moderated a little bit, but we've got more to come. We've got some of the coldest air of the season coming down. And Evan, I know that you've been looking at this. I mean, there was some snow after the Halloween storm, and then now we're looking at we've got the growing season done in a couple spots up in North Carolina, and there's more to come.
Absolutely. That growing season will be kaput after next week. We've got lots of hard freezes coming. But going back to what you said about the snow after Halloween, it was beautiful up above, I'd say 5,000 feet. If you're on our social media and you follow us, you probably saw some pictures of maybe about half an inch of snow, just a strong dusting on Beach Mountain and other locations. And it was actually cold enough for them to blow snow up at the ski resort. And Cataloochee opened on Sunday, I believe it was, just for the day. They'll be open again this upcoming weekend, but they are the first ski resort in the Southeast, and one of the first on the East Coast to open up this season. So enough random rambling. Let me go to what I actually prepared. All right. So over the next week, we're looking at 2 cold shots. The first one will be a little bit milder, although I shouldn't say milder considering it's still going to be very cold. Thursday night into Friday morning, most of the Carolinas are going to be seeing this cold front move across and filter in that first cold shot. It'll be lots of hard freezes, even potentially down into the I don't want to say I definitely would say the eastern parts of the states, even into those lower elevations near the coast. And that will be the first freeze that potentially ends the growing season for both of the Carolinas. In Asheville, we're looking at highs, potentially even into the lower 20s, and no real snow, and honestly not a lot of moisture with this system. And that's going to be the same story again. Tuesday night going into Wednesday, another cold shot. This one will be even potentially stronger than the one that we'll see Thursday night into Friday. It is still 6 days out, so we're trying to take everything with a grain of salt. and I'm not really going to be talking about any snow because I know that's being tossed around social media. And don't get me wrong, that potential exists. But the snow I will talk about is the northwest flow that the high country will be seeing Thursday night into Friday morning. And I know Ricky will probably want to talk about this again here in a minute. I've seen some of his posts, but maybe up to half an inch of snow up above 5,000 feet. After the front passes, potentially even a few flakes mixing in with the more synoptic scale moisture immediately along the front up above 6,000 feet. Just kind of a real light snow, nothing to get too excited about. Looking over the next 10 days, you can kind of see two distinct snow chances that we've been talking about. But again, if you look at the totals, I mean, a total snow mean across all of the Euro ensemble members is 0.2 inches. So nothing more than flakes Friday night, and then again next week. And don't get me wrong, that could ramp up, but for now, I'm not too excited about it, and it just warrants some watching. Same goes for the central and eastern parts of the Carolinas. There's been lots of talk in the Raleigh area. Ken Buckley has done a great job of handling it responsibly. But as you can see, once again here with all these different ensemble members, there's only a few members with any accumulating snow, and even still, none above 1 inch for that Tuesday, Wednesday time frame. But either way, snow or no snow, it's going to be really cold next week. More like, honestly, January than November. We're going to see highs anywhere from 20 to 30 degrees below average. This is a quick screenshot of Wednesday morning. So this would be the low Wednesday morning, and that's looking at, I mean, temperatures even as low as 40 degrees below normal up into the Smokies. This one model did show some snow in that run, so that's probably a little bit has a bit of a cold bias, whereas if there were no snow, it wouldn't be quite as chilly. But nonetheless, the whole area, both the Carolinas will see temperatures below freezing. Even in parts of the mountains, we could see lows down into the teens, wind chills down below zero in the valleys, and certainly above up on the mountaintops. Lastly, as I was kind of saying before, not much moisture to speak of with both of these systems. Generally, around half an inch, potentially even less from the WPC. Maybe a bit more up above up on Smoky Mountains, but yeah, two systems to look out for. Cold coming, and don't get all that excited about snow at the moment.
I think there's one other thing we're going to have to a lot of, Evan, is a lot of rime ice on some of our mountaintops too. Rome Mountain, Carver's Gap area, parts of Jefferson area, Boone region, places like that. With that event coming Friday night and then that prolonged northwest flow, probably a pretty good rime event up there Friday and then into Saturday. The interesting thing I think about the Tuesday storm is, it's one of those rain changing over to snow kind of setups right now on most of the models. And one of our good buddies, Joey, always said, never bet fully on a rain chasing snow setup. Never go big in North Carolina on that. And so it's going to be very interesting to see just how much cold air there is and how fast that cold air filters in. And also, I think a couple things may be working against us in that forecast. One, depending on where you're at in the state, could either be daytime or it could be kind of evening. I've seen an event come through where we didn't get a whole lot of anything in the Tri-Cities area, Northeast Tennessee, Southwest Virginia, because it was daytime. And when it got to the coast of Virginia, it was nighttime. And so things were actually able to stick there just because we lost the sun and the solar insolation of the day. So that may be something to look for on Tuesday. And then, of course, temperatures just with the rain coming before that as well. So always fun when we have to start forecasting snow in the second week here of November.
I know you have sarcasm in your voice, but for me, I think that's great.
Yeah, well, I mean, you need to come on up to Carver's Gap here one day, and we'll go recreate when I walked through a blizzard a couple years ago up there.
I snow chase up on Carver's Gap every year, and tell you what, it's beautiful in the snow. My favorite place to go.
It certainly is.
No, that's fantastic. Peter, you guys are going to deal with a fair bit of cold from this snap as well. How are things looking up in Jersey?
Yeah, we've been kind of dealing with the chilly weather already the past few weeks, and the chilly, damp weather since October. Halloween, we lucked out. We were supposed to get a really bad, rainy washout day, but trick-or-treating got in the amount of time that we do it, 3 to 8 here. And then it just poured overnight with a really bad gusty wind. So after that, it's been kind of chilly. We've been in the 50s pretty much since then. And now going into this weekend, we're supposed to be going down into the 40s for highs. Friday wind chills are going to be in the 20s and 30s. So yeah, we got cold weather coming, people. So real quick, GFS, you can see, look at all that purple out west. Doesn't that look very ominous? Yeah. Coming in for this weekend, going into parts of next week. We may get a few milder days in there, but then it just comes right back again as we go towards midweek and into late next week. And of course, the models keep throwing in some snow chances. We won't even get into that right now, but there is a possibility that something could come through, either rain, snow, mix, whatever. Who knows? It's still too far out. But Tuesday, Wednesday, Thursday time frame is what we're looking at. And we'll see what comes out of that. But it may be just a little too warm still for any kind of snow. So we did get a little bit of snow last year around this week and next week. So I don't know, maybe we'll have a little redo of that again. We'll see. So Jared, send it back to you.
Yeah, it's that anomaly map, that's pretty striking. I mean, keeping in mind that normal is warmer, this time of year than it would be in January, but I mean, those are pretty stout. So really stout Arctic air, a couple blasts coming in over the next few days. Shay, I know down here in Charleston, we've been in Ugg boots weather. We had an Ugg boot warning last week, and that has since been allowed to expire. But it looks like we might have to put another Ugg boot watch in place down here amongst us for the weekend and beyond. We're not exempt from this down here on the coast, are we?
No, we're not. We've had a couple of warm days here, and that's just typical of Charleston, right? I mean, we get a cool shot for a couple of days, and it gets warm for 2 or 3 days, and then the mosquitoes come back out and everything, and then all of a sudden, boom. So we have a cold front that's going to be approaching Friday, which is likely going to bring some rain with it. Immediately behind that, high pressure is going to be building across the country. We call it continental high pressure. It's going to be driving down a northerly wedge down into our area, and that's going to drive temperatures down very rapidly through Friday night. We're looking at getting into the upper 30s just inland and maybe low 40s along the beaches. Water temperatures are just getting down into the upper 60s, so that might keep things a little bit warmer just over the water. But with northerly winds, offshore winds, you're not looking at much relief there. If it was a southerly wind, you would. We start to get back into that southerly flow again Sunday into Monday as another cold front approaches. So we'll have a warm up again into those days. And then we have another larger area of high pressure building across the country. It's all in association with dips in the polar jet stream that are driving this cold air down along with these large domes of high pressure. And that's going to give us another big shot of colder air for next week. We're talking highs possibly in the upper 40s to low 50s, which for us in November, it's not too far out of the unseasonal values, but it won't last for too long, maybe 2 to 3 days from what I'm seeing. But we could see an elongated period of north to northeast winds along the coast, which that means an additional increase or risk for flooding. So we'll have to watch as the tides are starting to come back up again. We're out of the neap tides. We're getting out of the neap tide phase. We're going to be heading back towards another full moon phase. So we're going to be watching this very closely. If the winds stay more offshore, we're better off. But with the northeast or east-northeast wedge building down the coast, we're looking at not only colder air, but driving waters with more flooding. So lots of events over 7 feet this year, Jared. I mean, the Weather Service has released some of their findings, and it's pretty disturbing. We can't seem to get out of the flooding.
No, we can't. 76 events this year. And just a day or two ago, actually, the Weather Service office in Charleston released their statistics from 1980 to present day for Charleston Harbor and Fort Pulaski. 79 events, or 76 events in 2019. We're going to get to 79. I think we're going to clear 80 easily before this is over. We can't, like Shay said, we cannot stay out of the saltwater to save our lives this year. And it has been it's a real problem and it's underscoring a lot of the conversation, not just, in day to day, but, we have a mayoral race going on and all of that is over flooding. I mean, the flooding is one of the main issues being handled in the mayoral race. So, it's certainly something that has been a major problem. I guess the good news is that some of the flood control things that we have put in place, such as the check valves on some of the streets have been doing a pretty good job. We've got to see them in action a few times. Went driving down East Bay Street in downtown Charleston, notorious for pulling up very badly with salt water during a 7.8 foot tide, and it was smooth sailing, but you got down to the market and then they haven't fixed that yet. So a lot of work to do, stemming the tide of Mother Nature. So it is that time of year. We get these northeast wedges, and it's just seems to be part of the fall season for us now. Down here in Charleston. So
just look for some windy days for the mariners on the water. Be very wary about Saturday's winds in particular. Sunday we could get southerly wind. We also start to get in when we get these warmer air masses ahead of these cold fronts. As the sea surface temperatures drop and you get warmer air masses in, that creates or sets up marine layering, or what we know as fogging. So we can get these fogging events. We saw a little bit of that this morning. I'll give a shout out to my friend Mike McGee. He took some great pictures, even did some droning off the Ravenel Bridge up above the fog layer. So we have some fogging to look at. And then if you're on the water, that's going to be enhanced with the cooler air masses diving down with the warmer air masses. So you got a lot of mixing there of warm and cool air, and that creates a lot of instability, which means high wind events. So keep that in mind. Keep up with your forecast for the winds over your area, even if from the north can be pretty brutal out there across the harbor and offshore.
Yeah, absolutely. So, so we'll just, we'll put on our Ugg boots and then have the water boots on standby for when the tide inevitably breaches 7 feet in the harbor. And well, let's see. Let's just go for it. Let's just see how many flood days we can get this year, and just hope 2020 is better. But let's also be realistic that 2020 probably won't be better. As far as that goes. So anyway, as far as the weather goes, otherwise, down here in the Southeast, abnormal chill, baking out west. Their fire season is still going on in California. That's not going to abate anytime soon. So, troughing in the east, ridge in the west, and we're just going to stay chilly and occasionally unsettled. And that's that's November in a nutshell. So, if anybody on the panel wants to jump in, got any final thoughts before we sign off this evening?
I'm cheating on Cinnabon tonight. Go ahead, Shay.
Peter's always cheating on Cinnabon. He's cross-pollinating all of his products and confusing the potential sponsors. So I want to give a hats off to Levi Cowan of Tropical Tidbits, who received his doctorate this past week. So if you know who he is and you've been watching Tropical Tidbits for many years, he's had his website up and running. He's finally Dr. Cowan. So hats off to him for receiving that and going through his dissertation and defending his work, and he did very well. So, hey man, I'm happy for him.
That's fantastic. Tropical Tidbits is one of those indispensable sites, especially during hurricane season, which is thankfully dormant. We don't have any random batches of clouds being classified as subtropical systems. So yay! Very happy to see hurricane season fade out into the ether. And of course, by saying that, I'm sure we'll have something spin up tomorrow. But anyway, one last thing before we go. Unless anybody else wants to jump in with any final thoughts, any other final thoughts. But before we go, we do want to mention, we want to thank everybody for their outpouring of support for Scotty Powell and his mom. As you may have heard, his mom had a pretty significant medical event a couple weeks ago. The good news is that she's doing great. She's really coming along well. We're really thankful for that, and our prayers and our thoughts continue to be with the Powell family as she continues her road to recovery. There is a Facebook fundraiser for them. As you know, travel back and forth from Morganton to Charlotte is not, it's not free. Healthcare costs, we know that can build up, and so there is a Facebook fundraiser. We have it on the website. We're showing it on the screen right now. If you feel so moved to chip in a little bit to help the Powell family out, we know that we would appreciate it, and I know that they would appreciate it very much. But anyway, I continued thoughts, continued prayers for the Powell family and Scotty's mom, who is reading the updates is really coming through about as well as one can expect. And so still some things to go, but very encouraging nonetheless. So with that, that's going to do it for last 200 numbered show 299. Next week, 8/15, we will be celebrating 300 episodes of the Carolina Weather Group. We've been at this a long time. Ricky and Scotty started this, so 5-6 years ago now, something like that. It is just incredible what it's turned into. So we're gonna have a nice episode, a really cool episode showing some of our favorite scenes from the last few years of the Carolina Weather Group. First 300 episodes, hopefully 300 more to come. So anyway, so for the panel, I'm Jared Smith, and this will do it for the 299th edition of the Carolina Weather Group. We will see you same time next week. Take care.